Here we are, finding uncertainty. So the size of a square measured to be blah, blah, blah. And we want to get the area and the uncertainty. Now here we're not dealing with percent uncertainty, so we're going to break out the whole formula. So we got delta Q over Q equals delta A over A plus delta B over B plus delta C over C. This is, of course, assuming that Q is AB over C. Now, we're only dealing with the multiplication, so we only need two terms in this. So I'll just get rid of the C term and just kind of cancel it out here. So this is what we're dealing with. So first, let's get the area. The area is going to be 5 times 5, which is 25. Now, as far as uncertainty goes, so we're going to have delta Q over 25 is going to be, now each side, the uncertainty is 0.2 divided by 5 plus 0.2 divided by 5. And so we're going to end up getting that delta Q over 25 is going to be 0.4 over 5 when we combine. We'll multiply both sides by 25. 0.4 times 5 is going to give us 2. So when I look through the list of uncertainties, I'm going to end up getting 25 plus or minus 2 centimeters. So if you notice, we have like one, yeah, and that's it. 25 plus or minus 2 centimeters is going to be the correct answer when we multiply this out. We're not doing vectors in this unit. Now, a tennis ball dropped from a building, we have to worry about air resistance. So the short answer is this is the acceleration as a function of time, and let's recall how it works. So position as a function of time, we're going to start off from rest, speeding up, going forwards, and then we eventually reach terminal speed and go at a steady pace after that forever. So this is a curve, and this is, that was horrible. This is a curve, and this is a line. And then for the velocity as a function of time, we start off speeding up, going forwards, and then eventually our speed levels off to terminal speed. And for acceleration, we start off with an acceleration of 9.8 meters per second squared, gravity, and then our acceleration eventually dies off to 0. So that's how we're getting B. So you got to get those graphs memorized. Again, this will be a bonus point on the exam. Now, what is the? We're not going to do order of magnitude calculations yet. We'll do that a little bit later on. And then here. Now, if I want to get change in displacement, remember, so the rules are for V versus T, the area gives you displacement. For A versus T, the area gets you velocity or change in velocity. So we have velocity versus time. We want to get the displacement, so we're going to get the area. That's going to be 1/2 times 5 times 5. When I get that, it's going to be 12.5 meters. And that's how I'm getting B. Again, this is 1/2. I should be a little slower here. This is 1/2 base times height, which is the area. So there's the idea for that one. Okay, and again, I'm going a little quick because we've actually taken a look at these in class, and I'm expecting that you've taken some decent notes here. So, very important that we do that. Okay. Next, distance versus time. Again, we'd actually reviewed this before. For air resistance, it's going to be A, the graph where we start off speeding up and then we level off to a steady speed, and that's it. All right. So that's good for these problems here, and we'll take up more problems in our next video set.